All right, welcome back. Today, trig with a unit circle. So this would be section 2 in your book, 5.2. We're going to get started. So basically, here's what we're working with. We're working with a circle that has radius 1. Okay, and that's going to be the first way that we're going to kind of define these trig functions. And we're going to define them in terms of points where our angle intersects the unit circle. So you can see here I have an angle T drawn into my circle, and the point XY where the angle hits the circle. And that's how we're going to work on defining these trig functions here in just a second. Some of you, I'm sure, have done right triangle trigonometry before. And we're going to do that. That's in section 3. But the thing you really need to understand is that they're the same thing. And honestly, you can do trig either way. So if you know SOHCAHTOA, guess what? It's still going to be the same thing. So here's how that kind of works. If you drop a line down to the x-axis, there we go, and make a right triangle. Your right triangle has a base of x and a vertical side here of y and a radius of 1, and then SOHCAHTOA would apply. And so that's something we'll cover in section 3, but for now, just kind of hang on to it. All right, so ignore the bottom of my board here for just a second. We're going to define cosine, sine, and tangent first. Again, like I said, we're defining them in terms of these ordered pairs. So the cosine of an angle is just the x-coordinate where you hit the circle. That's it. The sine of an angle is the y-coordinate. The tangent of the angle is the ratio y over x. And that's really all there is. Once you know those definitions, you just pull them straight out of the point. We have these other 3 trig functions, secant, cosecant, and cotangent. And you'll notice I wrote that word reciprocals up here at the top. That's because these are the reciprocal functions, and you can find these in your book. It'll do a nice job of laying them out. But notice that secant is the reciprocal of cosine. Okay, so, and cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. So we're just flipping all those over. So anyway, if you have an ordered pair that's on your unit circle, in this case, here's my ordered pair. I promise that's it. These are 2's on the bottom, I promise. There we go, that's a little better. So here we have the square root of 3 over 2 and a half. And yeah, it looks weird, but it's a point on our unit circle. So the tangent of the angle, so again, pretend that this is my ordered pair, and I have an angle that intersects the circle. The tangent is just y over x, so I get a half over the square root of 3 over 2. Well, dividing with fractions is the same as multiplying by a reciprocal, so I do that. And of course, since I have a 2 on the bottom and on the top, those will cancel. They go away. And when I multiply, I get 1 over the square root of 3. Well, we don't like that square root in the denominator, so we're going to rationalize the denominator. Remember, you can get rid of the square root in the bottom by multiplying by it, right? So root 3 times itself is just 3. But we have to do it top and bottom. So that's how I get square root of 3 over 3. And that's how we're going to find these trig values. So I did a tangent one because it's kind of tricky. Or I should say a little more tricky. I mean, honestly, if we wanted the cosine of this angle, it would just be that square root of 3 over 2. If we wanted the sine, it would just be a half. And then obviously we have all of our reciprocals where you just take all those things and you flip them over. All right. All right. Continuing on. Now we're going to look at some special angles. These are in your book on page 418, except that they left out 0 and pi over 2, or 0 degrees and 90 degrees. It's important to know that with these angles, pi over 6, pi over 4, pi over 3, also known as 30 degrees, 45 degrees, and 60 degrees, I will want exact values. So if I ask you for the sine of 45 degrees, you go to the point, it's the square root of 2 over 2, and you have to tell me it's square root of 2 over 2. Please don't type it in your calculator. Okay, if you type it in your calculator, it won't work. By the way, typing into your calculator, that's where the mode that we talked about in lesson 1 really becomes important. You have to make sure you're working with degrees or radians with it. You're in the right one. Otherwise, you'll always get right answers. So I expect you to be able to use these. The good news is it's in your book, and so you can look at that. Again, it did leave out these 2 points, the 0, 1 for pi over 2 and the 1, 0 for 0. So you don't have to memorize them. You don't have to stick them on a note card. You'll have them. All right, let's talk about the sines. So we have the sign, the sign of all of these trig functions. Where are they positive and where are they negative? And what I've done with this chart, or with this graph really, because this is a graph, quadrant 1, 2, 3, and 4, is I've labeled where everything is positive. And so if you go back in the video just a little bit and look at how we defined everything, for instance, let's follow cosine. Cosine was defined to be the x-coordinate, right, on our circle, that where our angle intersected the circle. Well, x is positive in quadrants 1 and 4, so that's where cosine will have to be positive over here. Sine, on the other hand, was defined for y, and since y is positive on the top half of the graph, sine is positive in quadrants 1 and 2. Tangent and cotangent were defined in terms of the division of those two values, y and x, and so they are positive where both x and y are positive. So hence we get quadrants 1 of 3. So that's something we're going to use, because we're going to take all of this and put it together here in just a second to be able to find a lot more values. So we have these nice ones that you're supposed to know, and then we're going to take it and we're going to extend it all the way around the circle. And that's what's coming next. Okay, continuing. Now we're going to talk about reference angles. So a reference angle is always a first quadrant angle. Okay, the idea is we're going to throw everything back into the first quadrant. So it is an acute angle formed by the terminal side of your angle and the x-axis. So I drew a picture here. I have an angle that's down in the third quadrant, and the reference angle is this little itty-bitty angle in between the terminal side and the x-axis. Importantly, it has to be the x-axis. Okay, everybody always wants to go to the y-axis. I don't know why, but they do. Don't do it. Always go to the x-axis. All right, so for example, we're going to use subtraction to find them. With degrees, and we'll do radians on the next board, with degrees, let's say we had this angle of 210 degrees. The first thing we have to know is, where is this angle? Okay, and in degrees, that's pretty straightforward. Hopefully we can remember 0, 90, 180, 270, 360. Well, 210 is in between 180 and 270. So I just kind of throw it into the third quadrant. It doesn't actually matter exactly where it goes in the third quadrant, because we're just using it to kind of figure out what we're doing. So I know I want this little tiny angle right here. That's going to be my reference angle. I'm calling it T prime. And I'm just going to subtract. Now, importantly, reference angles are always positive. So whichever order you do the subtraction, you should end up with a positive. Don't do 180 minus 210. You'll notice I did 210 minus 180 so that I would get a positive 30. You should always get a positive. Here's a hint. If you get a negative, just drop the negative off. You did the subtraction. And that's how it works with degrees. Pretty straightforward. You figure out where the angle goes, figure out what you need to subtract, and you subtract. All right, now radians. So radians, let's say we have an angle of 11 pi over 6. Our first goal is going to be to figure out where it goes again. Now, this is where we talked about last time. You can always convert to degrees if you need to help you figure out where an angle is. But I'm going to just kind of point out, hopefully you are working on learning those 4 compass points. And if you do, we have pi over 2 and pi and 3 pi over 2 and 2 pi. But they don't have a denominator of 6. If they did, it would be so much easier to figure out where to put 11 pi over 6. So I'm just going to multiply to get the denominator I want. I want 6, so 2 times 3 gives me 6 on the top. Pi times 3 gives me 3 pi. Here, pi is just pi, so it's the same as 6 pi over 6, right? Just another name for 1. Again, multiplying by 3 down here, 3 times 3 is 9, 2 times 3 is 6. And 2 pi, 2 times 6 would be 12, so 12 pi over 6. You could always switch them to degrees and figure out where it goes, but here's the kicker. So we're going to do our subtraction. This is the angle we want. Remember, we always want to go to the x-axis. So please be really, really careful. It's going to be tempting to use this angle here to the y-axis because it's actually part of your angle, but we don't want it. We want this one right here. Okay, we want that one because that's the angle that's going to be in the first quadrant, right? This is less than 90 degrees. So I bring my subtraction up. I have to do 12 pi over 6 for 2 pi minus 11 pi over 6, and that gets me pi over 6. But here's the fun little sneaky bit. With radians, this is fun, for all the angles we care about, if you just drop the numerator, you have the reference angle. You drop the 11, you just get pi over 6. So if your angle is 2 pi over 3, drop the 2 and call it pi over 3. All right, last board for this section. We have some what are called Pythagorean identities. You'll find these on page 422 in your book. Basically, and I did a bad job of drawing it, but if you remember at the beginning we talked about how you could drop a line down and make a right triangle with a base of x and a top side of y. This is a right triangle, which means the Pythagorean theorem applies. So since the base is x, x squared plus y squared has to equal 1 squared. But here's the thing. We called x, or that x is what we called cosine, and y is what we called sine. So instead, we can write it as cosine squared plus sine squared is equal to 1. And just a note, cosine squared is the same as cosine of t squared. Okay, you find that cosine value, then you square it. And so this will always be true, that cosine squared plus sine squared has to equal 1. And it really comes straight out of the Pythagorean theorem. It's really pretty cool. Then we have periods for these functions. These are what are called periodic functions. All that means is that they repeat themselves over and over and over again. And you can probably kind of imagine that because what are we doing? We're going around and around and around the circle. And every time you get around the circle, you start over with the same set of ordered pairs. So the period is defined to be the smallest number where that repetition starts. For sine, cosine, cosecant, and secant, the period is 2 pi. You have to go all the way around the circle to start the repetition over. For tangent and cotangent, though, you only have to go halfway, just to pi. And yep, so those are our periods. And there we go.